Now, when we say the word universe, we're already picturing this vast space filled with stars, planets, and comets. Truth is, most of us find it hard to actually picture how large the universe is. Well, try to think of space as the biggest playground you've ever seen. Right now, our space playground goes on for 46 billion light-years. It wasn't always like that. On that note, you've surely heard of the Big Bang Theory. Let's try to unpack it. Imagine the whole wide universe, every star, planet, down to the smallest particle, squished into a tiny superhot ball the size of, let's say, an apple. From that point on, we've got a pretty neat roadmap of how things unfolded in the cosmos. Dive even deeper into the universe's past, and things start to get a bit blurry. The energies and temperatures rise, and suddenly, our rulebook of physics doesn't make sense anymore. When we reach these early times, gravity, that force that keeps our feet on the ground, starts acting all mysterious. This is where we bump into the great puzzle of our time, quantum gravity. And here's the honest truth, we've still got some homework to do on that one. What made the Big Bang go pop in the first place? Well, it's kind of like asking what happened before the first page of a book. There's no page zero, or at least that's the answer that quantum physics provides. It tells us that there are events in the universe that just, happen. It's not because we're not looking where we should, it's just how the universe works. Or at least, that's our current understanding of it. Right after the blast, everything was just a bubbly mix of gas, like this soda can that just got opened. This gas, which was mainly helium and hydrogen, began to stretch out and cool down. If we could time travel to those times, we'd see a younger, hotter, and cozier universe. Cool telescopes like the Hubble and James Webb let us peek into those ancient times. And what we see is fascinating. Earlier galaxies were like the cute photos of the universe when it was younger. Tinier, less heavy, and not as evolved as they are now. Over billions of years, the universe stretched out like a soap bubble. Imagine countless shiny marbles inside it, representing stars and galaxies. As the bubble grew bigger, the marbles spread out. Today, inside our bubble, we have trillions of galaxies. For every single galaxy we can spot, there are tons more we haven't seen yet. Some are too tiny, others are too far away. We still can't see them even if we use the fanciest telescopes available. Just to paint you a better picture, know that today our very own Milky Way is home to around 400 billion stars, similar to the Sun. It was a lot different in the past, though. Our galaxy began its journey like a little bundle of stuff, just a tad denser than most things in space. A lot of it was actually made of dark matter. Our closest star friend, named Proxima Centauri, is 4.2 light-years away. To put that in earthly terms, it's like taking a road trip around our planet millions of times. It's also about the same age as the Sun. If we could have looked at the exact spot about 5 billion years ago, it wouldn't have been there at all. Many stars live together in groups, kind of like families. However, most are solo adventurers, experiencing the vastness on their own. When you zoom out from our Milky Way and peek into the larger universe, it's more, empty, like a vast piece of countryside between big cities. In our cosmic area, we've got some cool neighbors. The Andromeda Galaxy, for instance, is just a stroll away, in cosmic terms, at 2.5 million light-years. And there are lots of smaller galaxies too, like the Triangulum Galaxy and the Large Magellanic Cloud. Our local hangout spot, which includes all these galaxies, spans about 3 million light-years. As we explore further, galaxies seem to gather in clusters, like suburbs. Connecting these clusters are threads of galaxies, creating a giant web in the universe. Galaxies are clustered this way because, just like magnets, they love to pull stuff towards them. If we could turn back time, we'd see a different picture. That's because throughout history, the popular galaxies with lots of stuff became even bigger, while the less popular ones gave their items away. From Earth, we can only see objects that are 46 billion light-years away at the most. If we put all this space into a giant box, its volume would be unimaginably huge. The main reason our universe is such a grand spectacle today is that it's been growing nonstop. Every year, its size increases a little more. In fact, the universe is expanding faster than the speed of light. Sure, we can't feel it down here on Earth, but there are clear signs in the universe that it's happening. We're still not sure why the universe behaves like that, but scientists are working hard to figure out this mysterious expansion. Our understanding of the universe has changed a lot over the years, too. Back in the day, when our world had more trees than buildings, people from all corners of the Earth would gaze up at a twinkling sky above. For many, the sky was their roadmap, alarm clock, and spiritual connection point. Now, imagine not having a smartphone or a compass and still being able to find your way home or knowing when to plant your crops. That's because our ancestors had the sky. They knew when it was time to take care of plants, navigate ships, or celebrate special occasions, all by watching the stars and planets. Long ago, people in Babylon spotted some stars that behaved a little weirdly. These stars seemed to have a mind of their own. Obviously, we know now that they weren't stars at all. They were planets, like Venus and Mars, that sometimes wink at us down here. There was also a time when we believed the Earth was flat. Well, at least some people did, before Greeks in the 6th century BCE figured out that it's round. They even managed to guess its size by watching shadows in different places. They were pretty close with their estimations, especially if you take into consideration their limited tools. Now, speaking of our planet, there was also a time when humankind believed the Earth to be the center of the universe. We also believed everything else was just spinning around it. That was until a man named Copernicus did a bit of research and figured out it was actually the sun coordinating all the movement in our system. And soon after, other thinkers and stargazers joined in on the fun, changing how we perceive the universe using new tools. Speaking of tools, thanks to a telescope, Galileo found out that Jupiter had massive moons tagging along. We call them the Galilean moons today in his honor. But the universe kept tossing surprises our way. Some people started cataloging stars, clusters, and nebula, while others found mysterious rays that our eyes can't see. And just when we thought we had it all figured out, Edwin Hubble, not the telescope but the man behind the name, discovered something amazing too. He realized that other galaxies are in fact moving further away from us. These days, we're looking at the universe in a different way. We know how the timeline works now. We know that our time here on Earth is limited. No wonder astronomers are eagerly scouting through the vastness of space, looking for planets similar to ours. There is no other planet that can safely accommodate us in our solar system. But we can use our neighboring planets and satellites for scientific purposes. Take Mars, for instance. In the following decades, NASA is planning to send all sorts of devices and even people up there. If the experiment proves to be successful, we might end up living there for a while, or at least use it as a pit stop for our next exciting destination.
Okay, so let's assume this teeny-weeny grain of sand, just about 0.1 inches in diameter, is our home planet Earth. Trust me, we're not even that big on a cosmic scale, so I'm flattering us a lot. You'll see. Anyway, the moon will be just about here, a little over 2 inches away, and we'll have to find a grain of sand that's 3 times smaller than the first one. It's hard to say if this is the one, so let's again assume it is. Now, what's the closest neighbor to Earth apart from the moon? That's right, Venus. It's called our sister planet because it's roughly the same size and mass. So this here grain of sand is gonna be it. As for the distance, we'll have to take a little walk now. And there we go, over 20 feet away from the grain that is the Earth. And that's at its closest, mind you. Next comes Mercury, and it's more than twice as small as the Earth. So let's take a grain of salt this time for variety. How far do you think it is from its neighbor, Venus? Not even close. It's here, almost 26 feet away. If you've ever seen a London double-decker bus, it's just short of that vehicle's length. Okay, Mercury is the closest planet to the Sun, so naturally, here goes. The big and mighty star, measuring as huge as this rock. It's roughly 8 inches in diameter, so it fits. Now, where should I place it? Well, you'd better take another double-decker, and then some, because the Sun's distance from Mercury is 30 feet, even further than Venus. And a walk from here to Earth is quite a trip already. All in all, the distance is just short of that between two baseball bases. Cool, huh? But we've only just begun. Moving away from the Sun, next comes Mars, which is twice as small as the Earth. Let it be a red pepper grain this time. The distance to it, though, is even greater than from Mercury to the Sun, over 33 feet. So, we'll place it here. And now, prepare for the real thing. We're crossing the asteroid belt to reach Jupiter. To do that, we'll need to travel about 275 feet. That's almost the height of the Statue of Liberty. And the planet itself is about the size of this grape, just shy of 1 inch. Now, let's take a smaller grape and fly another 330 feet. That's how far Saturn is from Jupiter. Can you still see our rock? Sun, from here? I don't think I can. Now, if you take the Golden Gate Bridge in California and decide to rise from its lowest to highest point, that would be the distance from Saturn to Uranus, the 7th planet in the solar system. Notice how distances grow larger every time? That's far from over, though. Meet Neptune, Uranus's brother planet. Although they're neighbors, it'll take us another 820 feet to get to it. Put 5 Olympic-sized pools in a line, and you'll get the scale. The former Planet 9, Pluto, is our next destination. If we go straight from the Sun, it'll be yet another 4 Olympic pools away, and the size of it is only a speck of ground pepper. Pluto is 6 times smaller than the Earth. And now comes the barely imaginable. Let's first go back to our Sun and start the journey from there. Remember how far that is? Right, more than a half a mile away now. To get to the inner boundary of the solar system from this point, we'll have to travel around the whole planet 4 times. Yep, we're still on the scale where the Sun is just an 8-inch rock. And when it's done, we'll find ourselves in a humongous belt of floating chunks of ice, the Oort cloud. The width of this belt is way beyond our planet's limits, but we'll try. Let's take 3 rocks of the same size as our Sun here and lay them in a line. And now, imagine each of these rocks is the size of the real Sun. That's the width of the Oort cloud for you, which goes in a circle around the whole solar system. If we put it to our initial scale, the Sun won't be even visible, no bigger than an atom. So let's scrap it now and start over, shall we? Okay, now this ring of stones contains within it the unfathomable volume of space. Its radius is roughly 1 light year, or 0.4 inches now, and that would be our ground zero for all the following discoveries. The closest star system from here is Alpha Centauri, and it will be about 1.5 inches away. It consists of 3 stars and at least 1 planet that could be inhabitable. The system is too small to see on this scale, but we'll pretend this grain of sand is adequate and proceed further. Next, we go to the edge of the Milky Way galaxy, our home. The galaxy itself is about 100,000 light-years across, but we're not far from its very center, so the journey will only take us 50,000 light-years. On the super shrunken scale we've created here, it will be 1,650 feet. If you lay down the CN Tower in Toronto, it'll only be a few dozen feet longer. From here, the nearest galaxy to us is the Andromeda. In some distant future, it'll collide with the Milky Way. But right now, to get there, we'll need to travel nearly 15 miles. That's 2.5 million light-years in normal count. If you're interested, it's also 2.5 depths of the deepest point in the Mariana Trench, known as the Challenger Deep. Next up is an object we could finally place on a larger scale. NGC 604, a star nebula located in the Triangulum Galaxy. If it were in a single line, we'd only need to travel 1.2 miles from where we are now, so let's do it. And the nebula itself is about 1,500 light-years in diameter, which is equivalent to 50 feet. That's like a 5-story building. But let's get back about half a mile and look at something else. This object is almost exactly the size of a Boeing 747, and surprisingly, it's a galaxy. A dwarf galaxy, to be precise. Messier 32 is 6,500 light-years across and is a satellite to the Andromeda Galaxy. They move together, Messier being tugged along by the gravity of its big sister. And now, I'm going to take you for a ride of your life. Get ready, we're going into distances and sizes that would seem impossible if they weren't true. Let's first get back to the circle of rocks that is our solar system. Moving up and away from our star system, we can see the Milky Way galaxy, spanning 0.6 miles wide. Shooting upwards still, we see the great emptiness around the galaxy that we've already crossed today, 15 miles of nothingness. Then, we see the galaxies and dwarf galaxies surrounding ours. First, the Andromeda, then others, until we're high enough to see the whole local group. It's a galactic cluster in which the Milky Way is no more than 1%. The diameter is 62 miles. But higher still we rise, and now we're looking at a bright and shiny Laniakea supercluster, which is home to the local group. From here, our galaxy isn't even visible. The diameter of the supercluster is about 3,200 miles. It's more than the distance from Los Angeles to New York. And even that's not all. Higher and higher until we see the boss Great Wall. It's a supercluster located unimaginably far from us. And on our current scale, its diameter is about 6,200 miles. That's longer than the Great Wall of China, with all of its branches. No wonder it's the boss. And finally, we're up in outer space now. Even though the model of our whole galaxy stayed so far below, you can't see it without a telescope. And we're now looking at the largest object in the observable universe, the Hercules Corona Borealis Great Wall. On the current scale, it's as far as 62,100 miles away from Earth, or a quarter of the distance to the Moon. And its diameter is the same, so it takes up another quarter of the way. There are trillions upon trillions of galaxies, nebulas, and stars, and nearly infinite possibilities out there. And yet, the universe is always expanding, so it's also only the beginning.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit, and at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, Nothing. It wouldn't change at all. All because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal. All because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Blah! But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about negative 370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.